All right, so welcome to the coding workshop of our day 2 machine learning project. So those of you who are watching on YouTube, you're welcome, and those of you in class, you're welcome. All right, so let's begin by going directly to the folder where we would like to carry out this coding, and then I'm going to copy this path to where I have my data set, which is called the energy data in .txt file. I'm going to copy this path. Then I'm going to go straight to Anaconda prompt and activate my environment. All right, so I'm going to move directly to the folder where I have my data set on drive D. And then I'm going to change the directory to the specific folder. And then I'm going to initialize my Jupyter notebook from the designated folder. All right, so I'm here on Jupyter Notebook. So the next thing I need to do is to create a new Jupyter Notebook script, a file. So I'm going to come over to the new button and then select Python 3. Okay, next I'm going to rename this script as the 2 machine learning project. All right, so this is going to be the practical implementation of our day 2 lecture. All right, so what we're going to be doing today, it's simply a step-by-step coding of the day 2 lecture. So we're going to have a line-by-line comprehensive explanation of the Python code to help learners understand data loading, cleaning, and visualization using Pandas and Matplotlib. So the first thing we need to do is to import the libraries. Okay, so I'm going to put that here. Right, so the first library is going to be Pandas. So we're going to say import Pandas as PD. And then next, we're going to import matplotlib.py plot as plt. So I'm going to run this cell by hitting on my shift and enter key. All right, so that's going to run. Okay, so next thing we need to do is to read the data set. So let's read the data set. So we're going to read and save that to a variable. So we're going to call that variable df, which is a data frame, in short, equal to, so pandas is represented as PD. So we're going to use that to read the data set. We'll say PD dot read underscore CSV because the format of our data set is .txt. And then we're going to specify the data set. The name of the data set is energy underscore data dot txt. Then we put in quote, and then we need to also specify that it's separated with a delimiter, okay, which is also known as a semicolon. So we say sep equal to quote semicolon quote comma, and then we also need to pass the data. What we need to do at this point is that we need to combine the date and time. Okay, we'll combine date and time, we'll merge date and time into a single date time column. So that is going to be, we say pass underscore date equal to, so we're going to have a curly bracket, then in quote, the name of the new column is going to be date time quote colon, and then a list. We'll have a list that consists of the column date, comma, time. So this is the exact name we have in the data set, the exact column name in the data set, or else it won't work. It has to be the exact name on the data set. And then we have to close that with a curly bracket. All right, so the next thing we need to do, we need to also help speed up the parsing by inferring the date time format automatically. We're going to say comma, and then we introduce a backward slash. So that tells us the code, the line of code is continuous. So in that case, we're going to infer underscore date time underscore format equal to true, comma. We're also going to specify the missing value. All right, so we're going to treat a question mark, which is a missing value in the data set. So we're going to treat that as a missing value. All right, so we're going to use this variable to say na underscore values equal to quote a question mark quote, and then finally we're going to set the low memory to false, which ensures more accurate data type inference, okay, at the cost of higher memory usage. So that is going to be low underscore memory, or set that to false. Okay, so once we do this, we're going to read this data set to this variable called df. All right, so the data set is actually gotten from this site, the cargo.com website, but then the data set is originally from UCI machine learning. Okay, so this is the original data set from the UCI machine learning. All right, so it was also made available on the Cargo website. So if you want to use the same data set for this project, you can actually find the data set on this link. It's free to download, and then you can use it and follow along with this step, with this tutorial. All right, so let's go back to our coding. All right, so let's run this cell. All right, so that is done. So the next thing we want to do after reading the data set is to inspect the data set. All right, so the first thing we'll do inspecting the data set is to use a print function to display the first 5 rows of the data set. All right, so let's say print into bracket df, which is the data that's been loaded into the variable, and then we say dot head, open and close bracket, and then we close the large bracket. Now if you run the cell, you're going to have information about the first 5 rows of the data set. And then you have the new column, which is the date time. All right, so that should be date time. I think we didn't spell that correctly. All right, so they should be date time, not data time. So I'm going to change that. It's going to be date time. So this is the new column we're trying to create by merging these two columns, which is the date and the time column. We want to merge it into a single column, call it date time. All right, so I'm going to run this cell one more time. Okay, so that we can effect the name change, so that we can see that. All right, so we have date time, we have the global active power, we have the global reactive power voltage, we have global sense intensity, sub-metering 1, sub-metering 2, and sub-metering 3. So this is what we talked about during the lecture class. Now you can see exactly how the columns that we have, the numbers of columns that we have, and what the data set looks like for each of these attributes. All right, so in that case, I'm going to run this cell one more time. All right, so to effect the name, so we have that date time. All right, so if you're wondering why the result is only showing the first 5 rows, so this is the default method, the default function of the df.head is going to display only the first 5 rows. Now the question is, what if I want to display the first 10 rows? All you need to do is to indicate the numbers of rows you want to visualize, or you want to see, or you want to display, by typing in the value within the parentheses, just like this. And then if you run this cell, you're going to get the first 10 rows. So you can see how that is done, how we can use Pandas to manipulate and analyze data. And then the question is, what if I want to see the last 5 rows? So all I need to do is to change the head to tail. So if I do that and I get rid of this value inside the parentheses, and then we're going to get the last 5 rows. If I run the cell, we're going to get the last 5 rows. Remember, the total number of the observation or the record is 2 million plus, right? So we're going to say that in other words, the numbers of rows is 2 million plus. Now we have the last 5 rows. Okay, and also if you want to generate the last 10 rows, you can also indicate the values within the parentheses. You're also going to get that as well. All right, so since we have done this, so we're going to take back to, well, we're going to take it back to head, and then let's keep it this way. All right, so next, let's inspect the data set. There are a few methods we can use to inspect the data set. So let's go. So we're going to use df.info. Okay, with the open and close parentheses. So this is going to give us some information about the data set. It's going to display the column names, data types, and count of known values for each column. All right, as well as useful details. Okay, this will help us understand the data structure and identify missing data. All right, so we could understand more about the data. So it tells us we have a total entries of 2 million plus observation rows. Okay, so we have 0 to 2075258. Right, it says we have a total of 8 columns. Okay, then it tells us about the data type. We have the date time 64. It tells us it's a float of 64, and then memory usage of 126.7 MB. So that's the size of the data set. All right, so we have another method in inspecting the data, which is known as the describe. So this generates descriptive statistics such as mean, minimum, maximum, and quantile for all numerical columns. So let's see how that works. So df.describe. Okay, we have the open and close parentheses. Then let's run this. So now we have descriptive statistics. Now we can see we have a count. Okay, we have the date type, we have all of these. We have the mean, we have the minimum, we have 25%, percentile, 50, 70, max, and then we have the standard deviation as well. All right, so since we have some information about the data set, now we understand how our data set looks like. We could see the features of our data set. We could see the range of the values for each of these features. Now, the next thing we need to do is let's handle missing value. How do we handle missing value? Now, the question is, you might be wondering, but there are no missing values. We can't find any missing values. So let's go straight to the data set, and then we can see, we can inspect this properly. Okay, so let's see what the data set looks like. All right, so I'm trying to open the data set. Okay, so let's see. Let's see what we have. All right, so let's wait for that to open. Then let's go back to, our code. Okay, so while we wait for that to open, so let's handle missing data. So now the next thing we need to do is that we need to know the rows with missing data. So what we're going to do, we're going to say df dot is not available. Okay, is now not available. Okay, dot sum, it means provide the total sum of the rows with missing data points. So we say sum. So we use this command to inspect and print out the rows with missing data. So this is going to check how many missing values are present in each column, so we can decide whether to clean or impute them. Cleaning means either to delete or impute them. So if we run this cell, it's going to tell us for daytime you have 0 missing values. For the global active power, it tells us the numbers of missing values that we have. So for the all columns, we could see that the missing values are at the same percentage, at the same values. So we have over 2 million observations rows. So it means we have about 25,900 rows with missing values. So what are we going to do at this point? We can actually delete them. We can drop these rows because at the end of the day, it's not really significant. So what are we going to do? We're going to drop these rows, okay, that contains missing value. So how to do that? We're going to say df dot drop, okay, we're going to drop now, okay, which indicates missing values contained in the column. So we're going to use this method, and then once we run the code, okay, now if you run this code, all you need to do is this. If you run this code this way, we need to save the output into a variable. So therefore, we're going to say df underscore clean equal to. All right, so it means whatever action we perform on the data set after dropping the rows with missing values. All right, so save the result into this variable called df underscore clean. Now, if you run this, it's going to run, but then you're not going to see your result. All right, so, but in this case, the data set has been cleaned. So how do we verify that the data set has been cleaned? All we need to do is to perform the inspection again to see if there are missing data. And if there are missing data, they should calculate the total number of missing data. So we're going to say df underscore clean All right, dot is now open and close bracket dot sum open and close bracket. So if we do this, this is going to tell us if there are missing values or not. Okay. All right, so we can see that for each of the column there are no missing values, all are all zeros. So we have verified that there are no missing values, that the data set is clean. So the next thing we need to do is we need to visualize the data set. So we'll need to use the histogram plot to do this. All right, so the first thing we need to do, we're going to use the library Matplotlib to achieve this. So let's go. We say plt, which is the alias for Matplotlib, dot figure. Okay, so this is the first step. If we do this, right, so this is the method from Matplotlib. Right, so we want to set up a new figure for plotting with a custom size. But now, if we try this at first, all right, so it's going to give us a figured size of 640 by 480 with 0 axis. All right, so what we need to do is let's customize this to 4 inches wide and 4 inches high. So what we're going to do to achieve this, we're going to say, what is the figure size? All right, so we say fig, which represent figure, we say size, right, equal to. So we're going to say 10, 4. Okay, and then a close bracket. So if we do this, it means we've been able to customize the size of our figure. Now, if you run this cell, you're going to see this. Right, so it gives us 1000 by 400. Right, so it means we've been able to customize the size of our figure. All right, so the next thing we need to do is we need to plot the histogram of the global active power, because our major focus is the global active power, which simply means it's the amount of power consumed by the household. All right, so we could see that as the second column. All right, so this is the global active power. So this is our major focus that is going to help us predict future energy demand. All right, so the global active power. So let's see how it looks like. Let's have a plot. Let's visualize it using the plot. So we're going to take note of this name. All right, the way it's written. Take note of the uppercase and the lowercase and the underscore. All right, so the next thing we need to do at this point is to use the clean data. We say df underscore clean. All right, so we're going to specify using the square bracket to indicate that this column is what we're interested in. We're interested in this column called global active power. All right, so we'll need to specify that this is a data frame, and then we'll say dot. This is histogram function dot histogram. So we need to specify the numbers of bin. We say bin equal to 100, and then we close that up. Then let's run this code. All right, so we have it, though there's an error, expected keyword bin, although we have a result. So what that means is it's supposed to be bins because it's more than one. So bin actually means that you have those groupings. Okay, you have 1, 2, 3, 4, 5, 6, thereabouts. So we need to indicate that these are bins, not bin. Okay, so we're going to introduce s and then run those code. and then we have this without any error. All right, so we could see the visualization of the power distribution. Okay, we could see the frequency. So this tells us we have more active power within this part. Okay, now this is looking a little bit, we could see height being distributed. Now if we increase this value by 1000, so the more the numbers of the bin, let's see the effect on the result. Okay, you could see, all right, so the width of the bin becomes very tiny, and you see more wave. You could see very tiny, and you can see the distribution, more wave. So this gives us an idea on the frequency, the distribution. Okay, the frequency distribution of the global active power. So if we take that to 10, let's assume we have 10. Okay, let's reduce the numbers of bins. Now, if you reduce the numbers of bins, you're going to see the effect. So the bin becomes larger, and then you could see the distribution. All right. So leaving it as at 100. Okay. Okay. Looks a little bit presented. Okay. Now let's go over to the next part. So what do we do? At this point, we need to give this a title. Now it's not appropriate and not nice for you to have a graph this way without a title. So the next thing we need to do is to introduce a title. So we're going to say plt.title, and then we need to specify what is the name of the title. So in this case, it's going to be global active power distribution. All right, so we need to include a quote because this is Python. It's a string, and then if you run this cell, you're going to get the title. All right, so now we've included a title, which is very nice. So it's a descriptive title to the histogram. The next thing we need to include is the label on the X and Y axis. All right, so we're going to label the axis to show unit of measurement. And then we're also going to label the y-axis to show how often each value range occurs. All right, so we're going to introduce another line of code. We say plt.xLabel. All right, so what would be the name of the label? We'll put that in code for the x-axis. So that is going to be the global active power in kilowatts. All right, so we're going to say global active power. So kilowatts. So that is the unit of measurement. All right, so that is kilowatts. And then we put this in quote, and then we close the parentheses. So let's run this. We're going to notice that we have the label on the x-axis. So we need to also include the label on the y-axis. So we're going to call this, so this is the y-axis. So what will the y-axis be? So it's going to be the frequency. So this is going to be the frequency. And then if we run this cell, we're going to have this. So we can see we have a plot well labeled. So the last thing we need to do is, although the histogram plot is displayed, but the next thing we need to do, we need to clear off all this extra information we have here, which is text into bracket 0, 0.5, frequency. We don't need that. All right, so we need to use plt.show, which is a method, and then it's going to show just the plot, display only the plot, nothing else. So this is going to get rid of those extra information on it. All right, so we've been able to go through step by step. Okay, encoding our plot, displaying the plot using Matplotlib. All right, so we can also display time series plot of the global active power. All right, so we use the histogram, and then we can also use the global, the time series plot as well. Right, so it's going to be similar to what we have. Right, so in this case, we're going to have the same function using Matplotlib. All right, so we're going to change the customize width dimension. We're going to say 14. So that will give us this. And then we're going to set the index. So we're going to use the date time. All right, because we're using time series plot. So it means we're going to set the index. So first, we're going to set the date time as the index to time, okay, on the x-axis. And then the plot, we're going to plot the global active power over time to visualize trend, spikes, or pattern. So this, we're going to use this line of code. We're going to say df, which is the clean data, df underscore clean. And we're going to say dot set underscore index. All right, so that will give us, we're going to use the date time column. So we're going to set this. Okay. Right, so we're going to set the index as the time on the x-axis. So this takes that, and then the global, we're going to have the global power over time, which is the column in our data set, because that's what we're interested in. And then we're going to use the dot plot function. Then we have the parentheses. All right, so if we run this, let's take this out. Let's have it within the same cell like this. That if you run this part, so we're going to wait for the results. All right, so we're going to have this so we can see we've been able to plot the global active power over time. All right, so over time meaning the data set was collected in December 2026 up till November 2011. All right, so we could see the global active power over time. All right, so we could see the spike, the time within the month where we have spike. So we can understand the pattern. We could see where we have very low global active power. We could see where we have very high. So this helps us visualize our data set. So the same thing we can actually give the title, okay? Just like we did initially, we could give the title, and also we could set the label for the same plot. All right, so to do that, all we need to do, okay, is to have plt.title. So we're going to give this global active power over time. So this is going to be over time, and then we're going to plot the y-axis. The x-axis is going to be time, and then the y-axis is going to be kilowatts, okay, which is nothing but the global active power. And then if you run this code, and then we should introduce the plt.show Okay, so this is going to get rid of all these unnecessary information that we don't need. So if you run that code, you're going to get the complete plots, all right, which is going to be rendered, which is going to render the final time series plot as well. All right, so if you've gotten to this part of this code, congratulations, for you have learned the basics of EDA, which is Exploratory Data Analysis. Thank you so much for being a part of this project, and I hope to see you in our next class, which is the day 3 of the machine learning project. All right, so enjoy your time and see you next time. Bye.